Historically, lunar exploration was defined by massive, highly customized events. Missions like the Apollo landings required immense effort to put humans on the surface for just a few days at a time before leaving the landscape empty once again. Flying to the moon, planting a flag, and returning years later creates incredible historical milestones, but it fails to establish a continuous human foothold. A permanent presence requires infrastructure that remains active and functional between crew rotations. NASA's recent analysis found that maintaining intermediate space stations in lunar orbit, like the Gateway project, requires a significant portion of the agency's deep space budget. Every dollar spent keeping an orbiting station alive is a dollar pulled away from building actual habitats on the surface below. Despite decades of spaceflight, the lunar surface remains largely undeveloped. We have left behind descent stages and footprints, but we have yet to build functional, lasting hardware that survives the lunar night. Staying on the moon requires abandoning the old model of one-off expeditions. The agency is now restructuring its entire operational architecture to prioritize long-term construction and surface permanence. During the Ignition event, NASA leadership announced a pivot. They are pausing the Gateway project in its current form. This decision directs the agency's budget and engineering power directly toward the lunar surface. The new target is an accelerated timeline. NASA intends to execute commercial, crewed surface landings every 6 months. To maintain this 6-month cadence without exhausting national resources, they are rolling out a highly structured 3-phase construction roadmap. NASA's Ignition strategy reclassifies the lunar surface as an active international construction site. By standardizing hardware and increasing landing frequency, the agency transitions from occasional research visits to permanent industrial development. Phase 1 begins with the current state of the lunar surface, raw, desolate, and devoid of the basic utilities required to support human life. NASA is using the Commercial Lunar Payload Services Program, or CLPS, to address this. By hiring private companies to deliver robotic landers at a high frequency, they can drop essential hardware onto the moon before any astronauts arrive. Precursor robots will drop autonomous rovers and radioisotope generators for continuous nuclear heat and power. These payloads will also establish the first dedicated communication relays to create a reliable navigation grid for future crews. Once that grid is active, the Lunar Terrain Vehicle, or LTV, an unpressurized rover designed for heavy driving, can navigate the terrain using the pre-laid power and communication nodes. Phase 1 is the foundation for survival. Without an automated utility grid generating power and mapping the terrain, sustained human operations are impossible. With the utilities in place, Phase 2 moves from scattered robotic tools toward semi-habitable infrastructure capable of supporting recurring astronaut visits. This phase relies on maturing commercial supply chains to provide regular, reliable logistics. Scheduled cargo runs must deliver the replacement parts and supplies needed to support larger machinery. The centerpiece of Phase 2 is a pressurized surface rover provided by the Japan Aerospace Exploration Agency, or JAXA. This pressurized rover allows astronauts to work in a shirt-sleeve environment for days at a time. Instead of staying near a static lander, crews can drive across wide geographic areas, using the vehicle as a mobile laboratory and living space. Integrating international hardware like the JAXA rover transforms the mission. It expands the operational area from a localized campsite into a wide-area exploration framework. Phase 3 marks the definitive transition from periodic expeditions to a permanent, continuous human settlement. This chart compares payload capacities across the 3 phases. To build a permanent base, NASA requires the Heavy-Duty Human Landing Systems, or HLS, shown on the right. These vehicles are designed to deliver multi-ton modules in a single flight. Using that heavy lift capacity, the Italian Space Agency will land their multi-purpose habitats. These large structures provide the permanent pressurized living quarters and long-term life support systems needed for a full-time lunar crew. To maintain these habitats, the Canadian Space Agency is contributing a lunar utility vehicle. This machine handles the heavy logistics and exterior maintenance required to keep the Italian modules operational in the harsh lunar environment. When these heavy components link together, the logistical loop is complete. The delivery of this international infrastructure creates the first permanent human foothold on another world. This plan demonstrates that the new moon base is a collaborative, plug-and-play ecosystem. It is an open platform where private companies and international partners attach their own modules, rather than a single facility built by a single agency. To keep this ecosystem alive, NASA is standardizing the Space Launch System rocket. Mass-producing a single, standard SLS configuration drops costs and enables the high flight rate required for regular resupply missions. This modular, recurring logistical chain replaces the isolated, bespoke engineering that defined the first era of space exploration. The technologies developed for these three phases, from nuclear surface power to the Space Reactor 1 propulsion system, are the technical requirements for Mars. By establishing flight heritage hardware on the Moon and building a compatible telecom network, NASA is creating the scalable, cross-agency framework needed to extend human presence to the Red Planet. By aligning commercial manufacturing with global space agencies under a phased construction plan, permanent human survival in deep space is no longer a theoretical concept. It is an active, scheduled endeavor.